Today's objective is that students will use angle relationships to find angle measures. So first we need to know some definitions. Adjacent angles. Adjacent angles are angles that have a common vertex and a common side. So if I look at this first figure on the left here, angles 1 and 2 are adjacent angles. Adjacent just means next to. But if I look at this other figure and I call this angle 3 and this is angle 4, angle 3 and 4 are not adjacent angles, because while they share a side, they don't have the same vertex, so they are not adjacent. Okay. Complementary angles can either be adjacent or non-adjacent. And what it means to be complementary is that the measures add up to 90 degrees. So on the left we have adjacent angles where they're sharing a side and a vertex. And then on the right we have non-adjacent angles, but they're still complementary because 40 plus 50 is equal to 90. Supplementary angles are angles whose measures add up to 180 degrees. And again, they can be adjacent, sharing a side and a vertex, or they can be non-adjacent. So supplementary angles add up to 180 degrees. Another angle relationship that we have is a linear pair. A linear pair, if you notice, if you look at the word linear, you see the word line inside of there. A linear pair is adjacent angles that form a line. Adjacent angles that form a line. So angle 1 and 2, if I add them up together, a line is 180 degrees, or a straight angle is 180 degrees. So I know that the measure of angle 1 plus the measure of angle 2 would have to equal 180 degrees. So whenever I have a linear pair, I know it's going to be supplementary. So that is actually a theorem that you'll need to know. All linear pairs are supplementary. This is something you're going to need to memorize. You need to know this by heart because we are going to use this a lot down the road when we get to proofs. Okay, so in your notes you might want to highlight that one. That's an important theorem. All linear pairs are supplementary. Alright, so for example 1, we have two angles that form a linear pair. The measure of one angle is 4 times the other. Find the measure of each angle. So in this case, they did not give us a picture, so that means I want you to draw it, because when you draw a picture, it makes it easier to visualize it and solve the problem. Okay, so it's a linear pair, so I know I have to have a line and a ray coming off of that line to form the two angles. it says one angle is 4 times the measure of the other. So if I call the smaller angle x, then the larger angle would be 4x. Now, because they're a linear pair, I know that they have to add up to 180 degrees. And so that means that my two angles added together, 4x plus x, would have to equal 180. Well, I combine my like terms, 5x equals 180, and then you divide by 5, and we get that x is equal to 36. So one angle is 36, and the angle that's 4 times as much is 4 times 36, or 144. So that would be the measure of each of the angles, 36 and 144. And if you check, you can see that those do add up to 180. Okay, another angle relationship that we will be using are vertical angles. Vertical angles are where the sides of the angles form two pairs of opposite rays. So basically, what that means is that they are the angles that are across from each other. Okay? Angles across from each other. So looking at my figure here, well, and they're formed by two lines. Okay, so looking at my figure, the angles that are across from each other, 3 and 5 are across from each other, so angle 3 and angle 5 are vertical angles. And 4 and 6 are across from each other, so angle 4 and angle 6 are vertical angles. Well, one of the things about vertical angles is that they are congruent to each other. So that's another theorem you're going to need to know. Vertical angles are congruent. So again, you're going to probably want to highlight that one in your notes. That's one you're going to be using a lot down the road. So since I know vertical angles are congruent, I can say angle 3 is congruent to angle 5. And I can say angle 4 is congruent to angle 6. When we're looking at diagrams, it's important to realize that you cannot assume anything, okay? You cannot assume anything. Unless it's marked. Okay, so looking at this figure on the left where I said congruent segments, I can't assume they're congruent unless those hash marks are there. Then I know that they're congruent. I can't assume angles are congruent, even if they look like they are, unless they have those two little arcs. And I cannot assume that an angle is a right angle just because it looks like it. It has to be marked with that box as a right angle. So if I look at example 2, I'm given a figure, what can I assume? Well, I look at it and I can say A, B, and C are collinear. That's something I can assume because it's shown in the figure. Okay, what I'd like you to do is pause this video and see if you can make a list of all the things that you think you can assume about this figure. Okay, so some of the things that you can assume is that ABC is collinear. The measure of angle ABC is 180 degrees. The measure of ABD plus the measure of DBC equals 180, or the measure of ABE, the measure of AEBC add those together, they would also equal 180. You cannot make any assumptions about right angles. Even though ABD appears to be a right angle, you cannot assume that because it's not marked. And you can't assume anything is congruent, even though it looks like AB is congruent to BC, or it looks like DBE is congruent to EBC. It's not marked, so we can't assume that they are congruent. There's probably some other things you could have come up with, but that's just a few of the things that you can assume from the figure. All right, so for example 3, we're going to find the value of x and the measure of angle 1. Well, these are vertical angles, and I told you that vertical angles are congruent. So in order to solve for x, I'm going to set the two expressions equal to each other. 5x minus 35 is going to have to equal 3x plus 7. And then you solve for x. So I subtract 3x on both sides and add 35 to both sides. And I get 2x is equal to 42. So when I divide by 2, x is equal to 21. Okay, that's the first part. I had to find that. Now I need to find the measure of angle 1. So I plug it back into the expression. It's going to be 3 times 21 plus 7. So that is 63 plus 7. So I know the measure of angle 1 would have to equal 70 degrees. And then that's also what angle 2 is going to measure because they are vertical angles. You can plug it in and make sure it works and make sure you did it correctly. Alrighty, and then for example 4, now I have a linear pair. I'm going to find x, the measure of angle 1 and the measure of angle 2. So in this case, because it's a linear pair, I know that they add up to 180 degrees. I didn't say anything about it being bisected, so I can't make them equal to each other, but I know if I add them together, 2x plus 1 plus 3x minus 31, that has to equal 180 degrees. So if I combine like terms, I have 5x minus 30 is equal to 180. Adding 30 to both sides, 5x equals 210. And then dividing by 5, I get x is equal to 42. So now I can go back and plug it in. 2 times 42 plus 1, 84 plus 1. So I get that angle 1 is 85 degrees. So obviously my picture was not drawn to scale. And then for angle 2, we'll do 3 times 42 minus 31. So 3 times 42 is going to be 126 minus 31. Okay, and so 126 minus 31, I get the measure of angle 2 is equal to 95. Thank you for watching.